There are three terms that need to be discussed before we begin the problem. The first term is the nominal curve distribution, which is this bell-shaped curve that in this curve the mean and median are typically equal, and at least 68% of the data that we are given falls within at least one of the standard deviations. Standard deviation is the square root of the variance that gives the average of distance or percentage from the mean, which the mean is the center. But in order to get the standard deviation, we need to know the variability. And variability is how far apart each unit will be from one another, and it all starts from the mean. Now that we got all the terms in, let's start with the problem. The problem is you score on the exam an 87, which in the follow scenarios gives you the highest score on the exam. So we have to go through each scenario to find out what gives us the highest score in the exam. So as we know, our score is an 87. And in scenario 1, our mean is 80. And our given standard deviation is 5. Therefore, it's going to be spread apart 5 units apart. And since our score is 87, it's going to go a little bit past, a little bit past 85. But this doesn't give us the highest score because the deviations are too far apart. So scenario 1 isn't the answer.
Okay, I will be explaining why scenario 2 is not the best scenario that would give you the highest score in the exam. So we have a mean of 75 and a standard deviation of 14. So in your first standard deviation would be 89, your second standard deviation would be 103, and your third standard deviation would be 117. Your first exam, your score was 87, and it's closest to the mean, 75. So that would explain why it would not be the best answer.
Now, in scenario 3, we have an exam mean of 84 and a standard deviation of 1. Keep in mind, our score is 87. So, when looking at this, we're at 84. Because it's a normal curve, that's where the majority of scores should be, up here at 84. And then as we go along, it should decrease. With our standard deviation being 1, it'll decrease relatively fast. So now that we have our normal distribution curve, looking at this, our mean of 84 is the highest point, where most scores will be, in the middle. Our standard deviation of 1 means that as we go up in units of 1 for our standard deviation. With our score of 87, it means that us, in terms of standard deviation of 1, we start at 84. If we go plus 1, we're at 85. Our score is still higher than that. A plus 2, we end up at 86. We're still higher than that. A plus 3, we end up at 87. Now at 87, we are higher than over 99% of other scores. So that's pretty high, leaving us in a very good situation. Now, if we look at our other scenarios, in scenario 1, we have an exam mean of 80 and a standard deviation of 5, which left us between plus 1 and plus 2 standard deviations. Not nearly as high as the plus 3 that we get in scenario 3. With scenario 2, our exam mean is 87 and our standard deviation is 14. This scenario left us between 0 and plus 1 standard deviations. Again, not high as plus 3 standard deviations. So if we want to be the highest in the class, or at least as high as we can be, scenario 3, with the exam mean of 84 and the standard deviation of 1, leaves us at a +3 standard deviation. So this is our best choice in the scenarios.